Hi guys, so in this lecture we'll be seeing aromaticity of compounds. So we'll be talking about aromatic compounds, anti-aromatic compounds and non-aromatic compounds. Okay, so let me first write the heading that we'll be talking about aromaticity in this video lecture. Okay, so let us first talk about the conditions for a compound to be aromatic, or conditions for aromatic compounds. For a compound to be aromatic, it must satisfy four of the below mentioned conditions, and they are Huckel rule. By Huckel rule, I mean to say that the compound must have 4n plus 2 pi electrons in it, where n can start from 0 to n number you want, right? Second rule is it should be planar, the compound should be planar. Third rule is it should be cyclic, and fourth rule is it should have delocalization of pi electrons, or simply delocalization. Okay, so delocalization I mean in full ring, in complete ring. Complete ring should be part of the delocalized pi electrons moving on around in its entirety of the compound. Okay, so now let us discuss about conditions for a compound to be anti-aromatic. Okay, so let us discuss about conditions for anti-aromatic compounds. Okay, so first condition is it should have 4n pi electrons, obviously n varying from 0 to whatever number you want. Second rule is it should be planar. Third rule is it should be cyclic. Fourth rule is it should have delocalization of pi electrons across its all carbons across its compound. Okay, so just to remember, you can just remember HPCD for finding whether a compound is aromatic, or H stands for Huckel rule, P stands for being planar, C stands for being cyclic, D stands for delocalization in the compound. Okay, so just remember HPCD and you can find any compound which is given to you, whether it's aromatic or anti-aromatic. Okay, so now let's take on some examples on the theory which we have learned. We have something like this. So does it, first of all we have to check whether this is a aromatic compound or non-aromatic compound or anti-aromatic compound. So I'll talk about what is a non-aromatic compound. So every compound which is not aromatic or not anti-aromatic is obviously non-aromatic compound. Okay, so let's check first for the Huckel rule, which is the H part. So how many pi electrons are there? 6. So actually it follows 4n plus 2 pi electrons, where n is equals to 1. Second rule is it planar? Yes, it is planar. All the carbon atoms are sp2 hybridized, and sp2 hybridized stays in one plane. Why? Because the angle between different atoms attached to carbon atom is 120 degree. Third rule is it cyclic? No. So that is the reason why this compound is not aromatic. Is it non-aromatic? Oh, or first let us address that is it anti-aromatic? So no. Why? Because number of pi electrons here are 6, and it is not following 4n pi number of electrons. Hence this compound is non-aromatic. Okay, let us move into the second example, where we have compound something like this. So you have to quickly tell me whether it is aromatic or non-aromatic. Okay, first calculate number of pi electrons. So number of pi electrons are 1 2 3 4 5 6. 6. Why? Because when you draw the resonating structure for this compound, you will easily get that this pi bond, this negative charge gets converted into a pi bond easily by having a bond between this carbon atom and this carbon atom. So this negative charge should be considered 2 pi electrons. Okay, so total number of pi electrons are 6. Is it following Huckel rule? Yes. Why? Because it is 4n plus 2 pi electrons. It is following. Is it cyclic? Oh, okay, first HPCD. Okay, so is it planar? Yes. Why? Because all the carbon atoms in this compound are sp2 hybridized. Okay, if you don't know about the hybridization, let me tell you that sp and sp2 hybridized carbon atoms are planar, means they will be having only xy or xz. Okay, I mentioned it wrong according to the convention, but someone can mention according to his convenience. So it should be either in xz plane, yz plane, or xy plane, any of the planes, but not in all the 3 planes, right? Those compounds are planar in nature, while sp3 hybridized carbon atoms are non-planar. They have tetrahedral structure. We will talk about this in our series of inorganic chemistry lectures. So you can go and watch those video lectures if you have any problem or doubt. Okay, so is it planar? Yes, it is planar. Is it cyclic? Yes, obviously it is cyclic. Is it delocalized? Yes, because the pi bonds and the pi bonds are circulated among all the carbon atoms of this organic compound, hence it is aromatic. Okay, now let us take example of the most popular structure. You know that obviously it's aromatic, but no, you have to prove it. So here is the proof. Okay, let us see if it's following HPCD. H, obviously there is this number of pi electrons. P, it is planar, all the carbon atoms are sp2 hybridized. I have told you many a times. Is it cyclic? Yes, it is cyclic, I can see it. Is it delocalized? All the pi electrons are delocalized among all the carbon atoms in the benzene ring, hence it is aromatic. Okay, let us take into some more example, and we have some structure like this. So is the compound aromatic, is the question. I hope you remember that we can actually convert this structure into a resonating form, because why? Oxygen has lone pairs attached to itself, so it can perform resonance. Okay, so it would have something like this. So now you can see that all the carbon atoms can involve themselves in double bond conjugation, and hence all the pi electrons can get delocalized within the organic compound. All the carbon atoms will get a share of pi electron in the resonance hybrid, hence this is obviously delocalized. Now we have to care about HPC. So number of pi electrons are obviously 6. It is planar, it is cyclic, I can see that, so it is aromatic. Okay, so let us compare the conditions we have for aromatic, non-aromatic, anti-aromatic compounds. So let's see that. So conditions for being aromatic. Conditions for a compound to be anti-aromatic, and lastly conditions for a compound to be non-aromatic. Okay, so let's discuss them. Obviously for aromatic it has to follow HPCD, which is H is the Huckel rule, or they have to follow 4n plus 2 pi electrons. compound has to be planar, it has to be cyclic, it has to be, the pi electrons have to be delocalized. Okay, conditions for anti-aromatic: the compound should have 4 and pi electrons, it should be planar, it should be cyclic, it should be delocalized. And aromatic, non-aromatic compounds, all of the compounds which are not aromatic, which are not anti-aromatic. It's that simple. Now let us compare the stability of the three. So the stability order would be something like aromatic compounds are the most stable, then comes non-aromatic compounds, then comes anti-aromatic compounds. Okay, so just remember this fact by heart and you will win by all chance. Okay, just remember it. Okay, so why actually are anti-aromatic compounds less stable? Because the electrons in anti-aromatic compounds are unpaired. We'll see more into the examples of anti-aromatic compounds in our next upcoming video. So till then, good luck and goodbye.